Hi there, my name is Mark Smith, and in this introductory video we're going to look at how you can use Xamarin and C# to build Android applications. The mobile computing space is expanding rapidly in several areas. On the consumer front, tablet sales have grown over 50% in 2013, and it's expected that they will surpass traditional PC sales in the next year or two. On the corporate side, companies are starting to target the mobile platform more aggressively, providing access to their information or services using tablets and phones. It is expected that just in a few years, almost all companies will be supporting multiple client platforms if they don't already. In addition, e-commerce sales using mobile devices has been steadily increasing year over year, and it's expected that by 2017 over 25% of online transactions will take place on mobile devices. In this expanding mobile arena, the current market breakdown suggests that iOS and Android are by far the most popular platforms, with Android clearly dominating in the phone market with almost 80% of overall sales, and growing fast in the tablet market as well. In just the past year, iOS and Android have swapped their market shares. Because of these trends, developers need to become more adept at targeting the mobile platforms available so that we can meet the upcoming application needs. Broadly speaking, there are two ways to build applications to run on mobile devices. The first is to create mobile-friendly websites using HTML5, JavaScript, and CSS. These are websites which change their appearance and layout based on the devices that they're rendering on. Most modern HTML frameworks, such as Bootstrap or Foundation, make this a fairly easy process. This approach is quite popular because it allows you to build a single site that can target all the platforms that include a modern web browser. For some types of applications, particularly news reporting or retail sales, it makes perfect sense to use this approach. However, there are downsides. Web-based applications generally require internet connectivity. They're going to be constrained to the capabilities of the browser and its navigation model, and of course, they cannot fully take advantage of the hardware features. For these reasons, many developers decide to build native applications which target the platform directly. With this approach, we can utilize all the features of the device, work offline, and ensure that our application fits nicely within the model for that platform. However, it has a dark side as well. As you can see, the three most popular platforms all use different programming models. Windows Phone and tablet devices use C# and .NET, Android applications are written in Java, and iOS applications use Apple's Objective-C language. This means that in order to target all three platforms, you will need to write the application 3 times. This, of course, increases your development time and costs. That's where Xamarin comes in. Xamarin is a set of tools for building applications for Android and iOS using C#. To pull this magic off, Xamarin includes an optimized mobile version of the Mono framework and runtime engine, giving you access to the common .NET features and classes that you're already familiar with. This has two main benefits. First, you can obviously use C# as your programming language. The compiler included with Xamarin is based on C#5, so it has advanced features such as generics, link, lambdas, and async await keywords. For me, that's reason enough to use Xamarin. You also have access to a large number of .NET framework classes, such as link to XML, the task parallel library, web services, and even portions of ADO.NET. Second, if you're targeting multiple platforms, you can share significant chunks of your application logic between them in either source form or as shareable DLLs. With this approach, we can write our application logic once in C# and share it across all three dominant platforms. Finally, notice the UI layer at the top of the diagram. Xamarin does not include any common UI widgets that are cross-platform. Instead, it is expected that you will use the controls and UI paradigms specific to the platform you're targeting. Xamarin provides bindings which allows you to access and manipulate these controls from C#, and you'll create the UI either using platform-specific tools or dynamically in code using C# to create the object graph. The benefit to this approach is that it ensures your application looks and feels natural on the device and fits nicely within the ecosystem. The key point of all this is there are no compromises your application has to make when using Xamarin. You have access to every feature available on the platform, and users of your application won't know or care that you use C# to build it. Xamarin.Android, sometimes referred to as Monodroid, is the cross-platform software and tools that allow you to build applications that target the Android operating system. It includes an IDE to develop your source code, a C# compiler to compile that code to IL, and a code-reducing linker, which along with some of the Android SDK tools, ultimately produces the Android package that can be uploaded to any of the Android stores or deployed directly to devices. Xamarin.Android also includes several runtime components which are included as part of your application package. First, a highly tuned mobile version of the Mono runtime is used to execute your code. This provides the same types of runtime services as the CLR, things like just-in-time compilation, optimized garbage collection, and type checking. It has tight integration with the Android JVM, utilizing Dalvik to execute Java-based components. Next, it includes an API binding layer. This provides thin wrappers for the Java-based Android APIs so that C# can easily work with all the built-in application frameworks, including the native UI controls. There's also support for creating your own bindings to wrap third-party Java components which you might want to use in your application. Finally, it has a full implementation of the .NET base class library for things like collections, threading, and I/O, as well as a subset of the framework libraries, which include higher-level abstractions such as Link, the Task Parallel library, and client-side web services. Your code then runs on top of this infrastructure, utilizing .NET APIs and Android APIs together to provide a highly performant, fully native application. To install Xamarin, all you need to do is go to Xamarin.com and click the download button. This will pull down an automated installer that will grab all the SDKs and tools necessary to begin building Xamarin-based applications. Here's the Xamarin website. By simply going to the root Xamarin.com domain, you'll end up on a page where there's a Download Now button. You can click this Download Now button and it will take you to that download page that was shown in the slide. Here you can enter your name, email, company, and give a little bit of information, and then download Xamarin specific for your operating system. Once you've installed Xamarin, you will need to decide which pricing level to use. There are actually several to choose from, and you should pick the one that's appropriate to the application you're trying to build. Keep in mind that each license is separate, so if you're building an iOS application and plan to port that to an Android application, those would be considered separate licenses and you will need to purchase both editions. However, both are packaged in the single installer, and so when you use the installer you will actually get Xamarin for both iOS and Android. If you need clarification on licensing, Xamarin has a pricing page and contact information available on their website. To begin with, there's the Starter Edition. This is for individuals and it allows you to create and deploy applications to devices or public app marketplaces. This is free, but has an application size limit imposed on it of 64K. This limit does not include the Xamarin runtime, but would be any of your code and extra DLLs that you include with your application. In addition, there's no support for custom bindings in this version, so you're limited to only what's provided by Xamarin itself. The Indian edition, for $299 a year, removes the 64K size limit and the custom binding limitation. The Business edition is likely what you'll want if you're part of a company. This is $999 a year and it's geared towards organizations and adds support for Visual Studio, so you can use the IDE that you already know to build your Android application. It includes support for talking to web services using WCF and an ADO.NET provider for managing relational data within your app. It also has support for ad hoc deployment. This is where you're deploying an app independent of an app store and are instead making your package available through some enterprise deployment that's part of your organization. Finally, you get private email support from Xamarin staff instead of the public forums used for free and indie editions. But of course you can still use the forums if you like. The Enterprise Edition is intended for large organizations and adds a 1 business day service level agreement as well as access to hotfixes for bugs prior to the released fix. You get a 1-hour technical kickoff session with a Xamarin engineer to ensure your project gets off on the right foot, and a library of pre-built themes and controls which you can use to jumpstart your development. With a few exceptions, you will be able to use any edition to follow along with this course. You can start with the free edition and then upgrade if it becomes necessary for you, or use the 30-day trial for the business edition if you'd like to try out some of the higher-end features for yourself. As I mentioned, part of the Xamarin install includes a free, fully supported, integrated development environment. This IDE is called Xamarin Studio, and it's available on both Mac OS or Windows. It supports a broad range of project types, including mobile, desktop, and web applications, and by lucky coincidence, or perhaps well-thought-out design, it utilizes the same solution and project file formats as Visual Studio, so you can easily transfer code that you've already built or open projects you create with Xamarin in Visual Studio. Let's look at building a simple Android application using Xamarin Studio. Xamarin Studio is an IDE which runs on either Windows or Mac and allows you to build cross-platform applications that target Mac OS, iOS, or Android. To start Xamarin Studio, just locate it in your Start menu on Windows or use Spotlight on Mac OS. Once you launch it, it will open with a welcome screen. You're seeing the one here from Mac OS. The welcome screen will show you current blog entries and news from Xamarin and some basic samples, pre-built applications that you can download and play with. Xamarin Studio is actually based on an earlier work from the Mono group, which was called Mono Develop. Mono Develop is still available and is an IDE based on Visual Studio. As a result, if you've used Visual Studio, you will find there are many common paradigms and features present in this IDE. It should be a fairly easy transition for you. One of the similar features you'll find is project organization. Xamarin Studio uses the same solution format and structure that Visual Studio does. In fact, you can open existing solutions and switch back and forth between the IDEs if you have the proper project types available. So let's explore Xamarin Studio by creating a simple Android project. To create a new project using Xamarin Studio, I can either use the New Solution button available on the welcome screen, or go up to the menu bar where I can use File, New, Solution. Both will open the same dialog, the New Solution dialog. Notice it's very reminiscent of Visual Studio's New Solution dialog, showing me a list of languages on the left and a list of project types in the middle with a description over on the very far right. If I select the Android projects under C#, you can see I have several different project styles that I can create with this tool. We can create an Android library project that will generate a class library to share code across different applications. This is essentially the same thing as the Visual Studio class library. We can also create a Java bindings library. This is used to create a C# wrapper around a piece of Java code. This might be an API that Xamarin hasn't exposed yet, or more likely a third-party component that you've downloaded off the internet. Then we have 3 application templates, starting with the Android application template. This will create a simple Android application that targets the most recent version of the SDK that you have installed. And this is generally what you're going to start with. We also have the Honeycomb application template and Ice Cream Sandwich application template. These are used if you'd like to actually start with a particular SDK version. Honeycomb is Android version 3 and targets API level 12, and Ice Cream Sandwich is Android version 4 and targets API level 15. We'll talk more about versioning a bit later in the course. We also have the OpenGL application template. This is useful if you're trying to build a game or some type of application that needs complete control over the screen. And then finally we have the unit test project. This is used to create unit tests to be able to test the functionality of your application and business logic. So I'm going to go ahead and use the Android application template. I'm going to give this project a name, My First Android App. And I'm going to tell it to go ahead and store it in the default location, which would be under my home folder. The solution name will follow the name of the project itself, and this will be the directory that the project template will create. I'll click OK to go ahead and generate the project. I'm going to go ahead and close this initial activity, and we'll come back to it in a moment. Before we do that, I'd like to just explore the UI that's present here in this newly created solution. First, I want you to notice that we do have a Solution Explorer over here on the left. This is actually called the Solution Pad. All of the little UI tool windows that pop up here are all called pads, and you can see there are several over here on the right as well. A toolbox, a property explorer, a document outline, and unit tests. It turns out you can turn these on and off through the View menu that's present on the menu bar. Notice there are pads within the view menu, and I can turn each one of these on and off. I can also dock them, so for instance I can open up the document outline. I can then click the little square button here to dock it. I can even drag and pull it off if I like, or I can undock it by simply clicking the auto hide and it will collapse back. I can then also close it with the close button, which would then require me to go back to the view menu to activate it. These are all called layouts, and it turns out the system actually has several built-in layouts, including the solution layout that we're in right now, a debug layout for using with the debugger, a visual designer layout, and a unit testing layout. You can create your own layouts and then delete any custom layouts that you might have built that you don't need anymore, simply by arranging the windows how you like them, and then choosing this new layout from the view and naming it. That will then save the layout and it would show up in this menu. That brings us back to the Solution Explorer. You can see that I have a single solution with a single project in it. You can, of course, have multiple projects and include dependencies between them so that the system builds them in the correct order. If we examine this project, it should have a fairly familiar look to it. We have a references folder that, if we open, shows us all of the assemblies that are required to build and execute this project. This includes the mono.android assembly, which would be the equivalent to MS-Corelib in the .NET world. I can right-click on this references folder and select Edit References to pull up a dialog that will allow me to add other assemblies to this project that I might want to use. For example, I might come down here and decide that I would like the system.json assembly to be able to parse out JSON requests. I can also select other projects within the solution, or even browse the file system and go find an actual binary on disk to be able to add to my project. We then have the Components folder. The Components folder is a placeholder for third-party components that you've downloaded from the Xamarin store. If you right-click on it, you can use the Get More Components to actually log into the store and then go find some component that you might find useful for your application. For example, here's the Azure Mobile Services component from Microsoft. This provides a nice object-oriented wrapper that's usable with both Android and iOS to access Azure Mobile Services. By simply clicking the Add to App, this would download the component and add it into my application structure, giving me access to this service using a very easy-to-use component. Next, we have the Assets folder. The Assets folder contains any data or content files necessary for your application to run. Anything you place in this folder will be deployed with your application and available at runtime using Android APIs. The project template includes a text placeholder file that gives you some simple instructions on accessing assets at runtime. We won't be needing any additional files in this first application, but if we did, this is where they would be placed. We also have a Properties folder. The Properties folder actually holds two files. The first is the Android manifest. This is a required file which describes the application, its name, icon, and version number. It also has a minimum Android version that our application requires from an API set in order to execute. You can also specify the ideal target Android version that you'd like the application to run on. And then finally, we can specify the permissions that we require for this application. Permissions are things like location services, accessing the camera, or using the network. Finally, down at the bottom, notice there's a Source tab. The Source tab allows you to edit this manifest in its raw XML form. This is useful if you'd like to add a custom permission, or perhaps a permission that's not exposed in the GUI. The second file we have inside this folder is the assemblyinfo.cs. This serves the same purpose as it would in a desktop application. It stores data attributes to describe the file assembly. The file assembly version listed here is separate from the application version. They're not required to be synchronized, and you can set them independently. The Resources folder contains application resources such as strings and images. It has three subfolders: Drawable, Layout, and Values. These are predefined containers for the resources that our application will use. Drawable stores images that we need inside of our application. So here you can see our icon.png. Layout stores XML user interface definitions. You can edit these by hand or in a designer. There's one included in Xamarin Studio. And then finally, Values holds XML-based string resources that are used by our application. Let's start by examining the main.axml file in the layout folder. This file defines the visual structure of the user interface for this application. It's defined in XML, but it has a custom extension of AXML so that Xamarin Studio knows to open it in the GUI designer. By defining our UI in a separate markup file, we gain the same benefits as HTML or XAML. We can design it with tooling and have a nice separate layer for defining our user interface. We can open this AXML file by double-clicking on it, and it will open inside of a GUI designer in Xamarin Studio. First, notice that we actually have a nice designer display showing me visually what this application is going to look like. I also have a document outline that I can expand to see it in terms of an object graph. I have a toolbox over here on the right where I can drag new elements in the design if I'd like to add other things to it. And then finally I have a property pad down here that allows me to change various properties of the selected element. I can also switch to a source view that lets me see this in terms of the XML that defines the layout itself. Notice the root tag is actually a linear layout element, and that's what actually contains the button that was present in my visual design. Android defines things in terms of layout elements, and so linear layout organizes things top to bottom or left to right. That's controlled through the orientation attribute that's applied to this element. In this case, it's set to vertical, which would orient things top to bottom. Switching back to the visual designer, if I click on the button, you can see that my property pad changes to show me a list of properties that I can alter for the button itself. And I want to highlight two of them. First, notice the ID property. It has a special syntax to it that allows the system to be able to generate a unique identifier for this button. This syntax is @+ID/ and then a unique name. Android uses numeric identifiers to load resources at runtime, and when you apply a name with this syntax, Xamarin.Android will generate a unique identifier and add it to a special resource designer file. You can see it over here. It's called resource.designer.cs. I'm going to go ahead and open this file, and you can see that it is an auto-generated file. We don't really want to add anything directly to this, although it is a partial class, and so you could create a secondary source file with the same name and add your own things to it if you really needed to. This has a single class in it called resource, which contains inner classes that actually identify the resource types themselves. And so notice we have a drawable class, an ID class, a layout class, and a string class. These classes correspond to the actual folders that we have inside of our resource structure. And so drawable identifies the icon that you saw over here inside my drawable folder. In the same way, if we scroll down, you can see that my layout has a constant integer called main that actually identifies with this main.axml that we were editing just a moment ago. We use these constant identifiers at runtime to be able to locate these resources and utilize them with Android APIs. Recall that the name of the button was My Button. We have a class here called ID. This is going to be used to represent any identifiers from any AXML files. And you can see here that there was a public constant created in here called MyButton. Don't worry so much about the constant values. Those are just generated by the build process. You won't ever edit those directly. You'll use these constants instead in your code behind to actually reflect these particular elements. Switching back to the GUI view, notice that the button also has an odd syntax on the text property. The text property is labeled as @string/hello. This declaratively identifies a particular string from our string resource table. That's in our values folder. If we open this up, you can see it's an XML file that identifies strings as name-value pairs. And so the name for the string is hello, and the value is hello world, click me. You can see that that's exactly how it's defined here. @string/hello identifies that string, and then the value of the button is hello world, click me. I have two ways that I can set this. I could type it by hand, or I can click the little button that's next to the property that will actually open up my resource table, and I can actually select a string here. So for instance, we could select the app name string, click OK. That would change the key to be @string app name, and now my button now contains the text my first Android app. I'm going to go ahead and switch it back just for completeness. So that's our quick introduction to the design surface. Let's close this and go to the final file inside of our solution, which is called mainActivity.cs. Activities represent screens in Android. Each screen the user interacts with in your application will generally be an activity that you've created or loaded. The project template creates a single activity called main activity. Opening it, you can see it has a traditional C# structure to it. We have a set of namespaces at the top to access .NET and Android types, and then have a single class defined in a local namespace. The class itself is public, although that's not a requirement, and it derives from a base class called activity. Notice that the class has an activity attribute applied to it. This supplies some metadata to the build process, telling it to add some tags to the XML Android manifest in our properties folder, so that this activity is registered with the operating system. Android will only display registered activities, and this automates that registration. When you have multiple activities, then you will need to define one of them to be the first activity to show to the user. That's the purpose of the main launcher property on the attribute. This must be applied to a single activity, and that one activity will then be marked in the manifest as the initial activity to display. Finally, the label property defines the text to display in the title bar for this activity. The activity base class has several overridable methods which are used to manage the lifetime and notify your code about the state of the activity as it runs. The starter project overrides a single method called onCreate. This is called by the operating system after it has instantiated this class, and it is the appropriate place to initialize the UI in preparation to it being displayed. In this implementation, we're using the setContentView method to initialize the UI to a layout file. This layout file is identified by the resource layout main constant, which of course comes from our resource designer.cs that you saw earlier. Recall that resources are identified by their numeric identifiers. That's what we're passing here. Once the view is set, it locates a button in that view using the findViewById method. This is a generic method that also takes a resource identifier, in this case the identifier for our button, and casts that return type to a button type. Once we've located the button by its unique resource identifier, we then wire up to the click event on the button. The click event is raised whenever the user taps the button on the user interface. And we can actually wire this up to a regular method, an anonymous delegate like what you're seeing here, or even a lambda expression. In this particular instance here, we're going to change the text of the button based on the number of times we actually click it. And so notice we're capturing the state of a field that's declared here at the main activity class, incrementing it, and then supplying that as the text for the button itself. Now that we've gone through this sample template and code, the next logical step is to build and run the application. But in order to do that, we have to have a device to run it on. Android's available on a variety of devices, over 1,000 different vendors and manufacturers at last count. You can find Android running on everything from appliances to automobiles. Not all devices allow custom application development, but even accounting for that, the market's quite diverse due to OEM variations. This diversity means that devices can have a variety of form factors, screen sizes, and capabilities, which applications must be able to handle if they want to distribute across the entire Android ecosystem. Add to that fact that Google releases a new version of Android on average every 3 to 6 months, fixing bugs and adding new features. To put that into perspective, in the last 4 years, there have been 9 major releases, all named after desserts, the most recent being Kit Kat, which was released in October of 2013. Because Google does not mandate updates to the manufacturers, and most OEMs tend to alter the operating system in subtle or not so subtle ways, the adoption rate tends to be a bit behind. As of November 2013, Jelly Bean, the predecessor to Kit Kat, is the most widely adopted Android version, operating on approximately 52% of Android devices. But as you can see from this graph, there are several major manufacturers that are several releases behind. That means that if you require a feature on a newer version of Android, you will either need to add runtime checks to ensure that the feature is available, or potentially alienate a portion of the market from your application. All of these factors are going to increase your testing requirements. There are 3 primary ways to test your application as you develop or change it. The first is to use a physical device. You should always test on a physical device of some form. A real device is the only way to test things like multi-touch and most of the sensors. It's a fairly easy task to do this. You'll connect the device via a USB cable, turn on debugging options on the device to enable USB deployment, and then you'll be able to deploy your application directly from Xamarin Studio. However, it's impractical to purchase every possible device combination that your application can run on. So you can use the Android SDK emulator. The emulator actually runs the Android ARM or x86 image and is capable of executing your code on a PC or Mac. It's built into the SDK, and every possible combination of form factor, display size, and OS version can be accounted for with this technique. The third option is to use a virtual machine to execute the image. You can download Android as an ISO image, and because it runs on top of Linux, you can install that image into your favorite virtualization software, VMware, Parallels, and Hyper-V being the three leaders here. Parallels even has a pre-built image you can download for free that's already configured. This approach tends to be faster than the emulator approach, but isn't as configurable or as easy to use. Since the emulator is the most common approach, let's look at how to create and configure an emulator using the Xamarin tools. If you recall, we left off with the standard project template where we have this one single main activity. When I want to build this application, I can go to the Build menu and select Build All or Rebuild All. Alternatively, I can actually build and run it using the Run menu, where I can just execute the application directly, or I can start it under a controlled debugger, where I could then inspect the application as it runs. I can also use this Start button on the toolbar. This is equivalent to the Start with Debugger option. So if I click this, you can see that it builds the application, and then it prompts me for the device that I'd actually like to run it on. In this case, I have a Google Nexus 7 tablet plugged into the computer via the USB port, and you can see that it's showing up here in my list. And so if I select this, I could actually then run it on this device. However, that's not a very compelling experience since you can't see the screen. And so instead, what I would like to do is actually create an emulator image. Now, I can actually do this through one of three different mechanisms. I can click this button here. That will launch the Android Virtual Device Manager where I can create an emulator. Alternatively, I can go up to Tools and select Open Android Emulator Manager. This will launch the same screen. Finally, I can actually launch it directly through the Android SDK itself. Now, before you actually create emulation images, you should go open up the SDK Manager. This is also available in the Tools menu. That will open up a new dialog here where I can see all the SDK pieces that I have installed. Notice it does a scan to make sure I have the most recent copy of all the tools here. And then I can go through and actually select the specific versions that I want. What you're going to want to do is actually go through this list and select specific images that you would like to actually run against. So for example, if you wanted to test against KitKat, the latest release, that's 4.4, you would make sure to download both the ARM and the Intel x86 system images for that release. You can also go backwards in time and pick up Jelly Bean, or I can pick up the ARM, Intel, and MIPS image for this release, and if I keep going backwards, you can see we can go all the way back to Cupcake, which was 1.5. Now, once I have my images installed, then I can go to the Emulator Manager, and I can create a new emulation device. Now, this is the Mac OS version of the UI. The Windows one will look very similar. There's a Device Definitions tab where I can create a new device or I can edit one of the existing devices here. This lists common devices that I might like to test under. For example, the Nexus 1 is a phone device from Google that I could test against. The Nexus 7 is a tablet device from Google that I could test against. Notice we also have the Galaxy Nexus, and if you scroll down a little bit further, then there's some more generic versions here that are just named based upon their screen resolution and size. You can also create your own device here, or you can clone an existing one to make specific changes to it. I can then go to my Android Virtual Devices tab, click the New button, and actually create a new emulator image. So let's call this KitKat ARM. I'm going to go ahead and select a Nexus 7, that's a tablet device, as my emulator type. I'm going to go ahead and pick Android version 4.4, and I'm going to pick the ARM version of the CPU. I can then decide if I would like a hardware keyboard to be present. This would be some buttons that I might be able to press on the emulator so that I can control the device. I can decide if I would like to attach a front camera to it, either an emulated one or a physical webcam that I might have. Some of them have a back camera, so depending on the device, if it has a back camera available to it, then I could use the back camera option as well. I can specify how much memory I'd like to have, and I can even say how much external storage I would like available. Then I have a couple of emulator options. There's a snapshot option. This basically allows me to persist the current state of the emulator between launches. This also improves the performance of the emulator as it starts. There's also a Use Host GPU option. This enables hardware acceleration for the graphics system on the emulator, and this will improve the performance of the emulator overall. Unfortunately, these two options are mutually exclusive, so you can't actually select both of them at the same time. You can only pick one or neither. I'm going to go ahead and pick Use Host GPU just to speed the entire emulator up. And then I'm going to click OK. This will then create the emulator, and now I have it in my list. I can close this dialog, and now when I click the Run button, it'll actually list both my physically connected device as well as the emulator. Notice the emulator has not been started, but I can click the Start Emulator button here, and that will then launch the emulator. This will take a few minutes, and you can see that I have my hardware keyboard over here where I have volume buttons, a power button, home button, etc. Once the emulator launches, then I can come back to my dialog. I can select that device, and I can click OK to launch my application. This will deploy the application to the device, install any shared runtime that's necessary for the emulator. This is the mono runtime itself. And then it will begin execution of the device. And so notice that if I switch back to the emulator, my application will then eventually launch. Now, the ARM emulator is going to be significantly slower, and you'll notice that your CPU utilization goes way up. And so my guess is your system will run a little bit hotter when you're using this version of the emulator. But once everything's installed and it begins execution, you can see that we see output showing up here in my output window. This is coming from the emulator itself. So Xamarin Studio hooks into the output log of the emulator and begins to display specific messages for that. And then you can see my application launching. I see my button, Hello World, click me. I click it. Clicking would simulate a tap on the device. And I can see 1 click, 2 click, 3 click. Because I started this in the debugger, I can go to this main activity, come down here, and I can put a breakpoint on this line by clicking in the margin area, just like you would in Visual Studio. When I switch back to the emulator and click the button, notice I'll now stop on this breakpoint. I can hover over elements to get tooltips indicating what their current values are. I have a call stack showing me exactly how I got to this point. I can see the threads inside this application, my current breakpoints, any locals that are part of this method, and of course a watch window where I can add new watch elements. And then I have a toolbar up here that allows me to continue execution, step over, or step into a method. So I'm going to go ahead and say continue execution. Let's switch back to the emulator. I can click the home button to get back to my home page, and you can see it really is running an image here. And so here's all the different applications themselves. It will be a bit sluggish because, again, we are emulating an ARM system on an x86 machine. When I click and hold this element, I can then come up here and uninstall it. Once I'm finished, I can then close the emulator. Now, when I try to run this again, you'll see that it will prompt me for my device again because the emulator is no longer running. If the emulator was still running, it would actually run it on the existing emulator that was there because we'd already started it there once. This time I'm going to create a second version of the emulator just to show you that we can create multiple operating systems here. I'm going to say new. Let's call this Jelly Bean, x86. So I'm going to go ahead and create a phone device this time. Let's use a Nexus 1. I'm going to pick Android 4.3, which was Jelly Bean, and I'm going to pick the Intel Atom x86 image. Everything else I'm going to leave the same, except I'm going to go ahead and again select my Use Host GPU. Say OK. Let's go ahead and close this. Now I can see I have my Jelly Bean x86, and I'm going to say Start Emulator. This will again launch the emulator. Because we're running on the same architecture as the host, you'll see that this version of the emulator will run quite a bit faster. Now, one thing you can do to improve the performance of your x86 emulation is you can download the Intel Hardware Accelerated Execution Manager, or HAXM. Just search for that with Google. Download this emulation manager here and install it. There's a version for Windows that you can see here, and there's a version for Mac OS. Make sure if you're running Windows 8.1 that you install the hotfix that keeps it from causing a blue screen. There's also a hotfix for Mac OS Mavericks. So this is the latest version of Apple's Mac OS operating system. Make sure you install that as well so that it runs properly. This will then accelerate the emulator significantly. If I switch back to Xamarin Studio, and I go ahead and make sure that's selected, there we go, click OK. This will then deploy to the device, install the runtime, and so you can see it comes up quite a bit quicker. And everything still works, including the debugging experience. So that's using the emulation system with Xamarin Studio. Now that you've seen the basics of building an application and running it on the emulator, let's make a few changes to this application. I'm going to start by going into the main AXML file. Recall this is our UI file that describes what the application is going to look like. I'm going to go ahead and first add in a new text element into this. This is a text view, and there's actually 4 to choose from here. We have text large, text medium, text small, and then just text view. They're actually all the same. The only difference is what the initial size of the text actually turns out to be. And you can change that by going to the text appearance property here on the style page, opening it up, and then changing the text size. For example, I could set this to be 48. Now notice that it sets it to 48 dp. There are actually multiple units that you can specify inside the property boxes. You can use px to represent pixels, in for inches, for millimeters. For fonts, we can use pt to represent point sizes. This would be 1/72 of an inch based upon the physical size of the screen. dp, what you're seeing here, is density independent pixels. This is a unit based upon the physical density of the screen, and they're relative to a 160 dpi screen, so 1 dp is 1 pixel on a 160 dpi screen. The ratio will change based upon the screen density. SP is scale independent pixels. This is like the dp unit, but it's scaled by the user's font size as well. Generally speaking, try to never use anything but SP or dp in terms of your screen elements. This will make your Android applications compatible with multiple screen densities and resolutions. Now I'd like to change the actual text that's present here. And so I'm going to go to the text property, and I'm going to click the little ellipse element there, and I'm going to select this hello string that we're using for the button. And I'm going to go ahead and change the button's text to, instead of using this, I'm going to call this just start. And then lastly, I'm going to go ahead and change the name of this text view. Let's go ahead and call this color text. I'm going to save that. And then I'm going to go to the strings XML, and let's just change that hello world to be hello Android. This is no longer a button, so we don't need the click me text. So everything should be kind of the way we want it in terms of our UI. Remember, this is called color text. I'm going to go ahead and close my main AXML and come back to my code. And I'm going to build the project here just so that the code can see all the elements, all the IDs that we've defined here. Now everything up to this point is actually okay. I'm going to delete this count. We won't need that. But we still have this button in here, and now we also have a text view. And so I'm going to go ahead and put a field at the top here to represent that text view, and we'll call it just color text. Let's go ahead and locate that in our UI. So I'm going to use this same find view by ID, but this time it's going to be a text view. And I want to use resource.id.colorText. That'll then give me access to this element from within my code behind. I'm going to get rid of the handler here, or rather the code that's in the handler, and I'm going to add a new method down here at the bottom. This method's going to change the text color each time that we click the button. And in fact, what I'd like to do is have the button basically create a timer and then have the color text be shifting while the timer runs. So let's go ahead and create a new method. We'll call it change color. And then inside this method, let's create a random element. So this is an element out, or this is a class rather, out of .NET. And then what I'd like to do is go ahead and use a little bit of reflection to pick up some basic colors that we already have access to. We're going to use the type of color. And let's go ahead and use Option Enter, which in Xamarin Studio will pull up this drop-down to be able to add our references automatically. And then let's just say Get Properties. And then let's use a little bit of link. This comes back with all the properties that are defined on that color type. So what I'd like to do is go ahead and constrain it to be just the ones that are color elements. And so we'll say where the property type is equal to type of color. Now notice where is not defined here either, and so I'm going to go up to the top of my application and just say using system link. And now that's valid and will show up. And then we can say select. And let's go ahead and cast this to a color element. And then finally, let's turn it into an array. That'll give me a nice array of colors that we can then use with this. Then what I'm going to do is I'm just going to have this sit in a loop. So let's put a Boolean at the very top here. I'm going to mark it as volatile because we're going to be changing this Boolean as we run the application. Let's call this our stop flag, and I'm going to initially set it to true, indicating that it's stopped. And then we can say while not stop flag. Then what I'd like to do is wait for just a moment. So we want to do a tiny delay, and I'm going to use the task class. The task class has on it a nice delay method that we can call and pass in a millisecond value. And this will actually spin off a task or a timer that blocks for 250 milliseconds, and then the UI thread will continue. And what I'm going to use here is the async await capabilities added into C#5. And so I'm going to put an await in front of this that essentially will allow the UI thread to return back to the caller and continue doing UI things, and then 250 milliseconds later the UI thread will wake up and it will come back into this loop. And so all we need to do here is just take our color text and change the color. And so let's call the set text color method. And let's go pick up a random color. And that'll change the text color. Next, in our button handler here, let's go ahead and start and stop this. So let's say first, stop flag is equal to not stop flag. So we'll flip the flag. And then let's say if stop flag is now set, then let's go ahead and call our change color routine. Change color will loop while the stop flag's not set. And so each time I come in here, we'll flip this, and this routine will either end or it will start. Then let's go ahead and set our button text. So let's just set the text property of the button to be stop, else let's set it to start. Now, if you recall, we already did that on the element itself, and so it initially starts out with a start value, and so we'll just flip it as we come through this little routine, our button handler here. Okay, I think that's all we need to do. Let's go ahead and try to execute this. And you can see it comes up. I click the start button, and that begins changing the colors. When I click the stop button, it stops changing colors. So in recap, you've seen how we can use C# to build an Android application, debug it, run it against the emulator, and utilize some of the advanced features of the .NET framework. All from within Xamarin Studio, running on Mac OS. Let's switch gears now and take a look at what this development experience might look like if we were running on Windows. When you install the Xamarin toolchain on Windows, it installs Xamarin Studio, and you can use that to build your applications. But if it detects Visual Studio on the machine, it will also install project templates into Visual Studio, along with some IDE extensions giving you access to the Android Screen Designer, emulators, and SDK Manager. Unlike the iOS version, which requires a Mac to build your projects, Xamarin Android applications can be designed, developed, debugged, and deployed right from within Visual Studio using this added support. Remember that this is a paid edition. You must have the Business Edition of Xamarin to use this feature. You can either buy a license or use the 30-day trial. Let's check out how to use Visual Studio to build our Android applications. So here we are in Windows. This is Windows 8.1 with Visual Studio 2013. I've already installed the Xamarin SDK, and so we have all the tools already integrated into Visual Studio here. And so I can go to New Project, and under Visual C#, you'll see I now have a new section here for Android apps and iOS apps. This was added by the Xamarin installer. So we can click Android application and create our tip calculator app. And notice it creates a solution that looks just like the one that we saw in Xamarin Studio. So you can see that we have the same references. We have the assets folder, the resources folder that has our 3 subfolders, drawable, layout, and values. And then we have our starting activity. Instead of main activity, it's just called activity 1, but we can of course rename it to whatever we like here. This has the activity attribute applied to it, and it's marked as a main launcher. Now what I'm going to do is I'm going to go ahead and delete all of the code that's in here, because I want to take a different approach to building my application. We could use a designer, and in fact if we open up layout you can see there is a main AXML here, and if I double click on it, it even opens the same designer inside of Visual Studio here. I'm going to go ahead and delete this because I don't want to use the design surface here. We could, but we're not going to for this particular application, but I just want to point out that all the same features are available here. I have the same toolbox, the same property explorer, everything else that you saw in Xamarin Studio can be done here as well. So I'm going to go ahead and delete this main AXML file. And instead, I'm going to create the UI directly in code. This is the second way we can build a UI using Xamarin, is by overriding the onCreate, just like we did before. And inside of onCreate here, I can actually just build my UI up in code. Now my goal here is to build a tip calculator where I could type in the price of my meal and have the application then tell me what the appropriate tip would be along with the total. And so to start out with, we're going to go ahead and put a linear layout element into the design. So we'll just call that layout. And notice that it takes a context. And so there's 2 constructors, both of which you must supply a context to. The context is actually just the activity owner. Activity ultimately derives from a class called context, and so we can simply pass our this reference here anytime that a context is required. We'll go ahead and set the orientation. Let's go ahead and set that to vertical. So this is going to lay this out as a series of rows versus columns. Then let's put in a text view field. This will be our price label. Again, we have to pass a context. I'm going to go ahead and set the text size. And I'm going to go ahead and set the padding for this. So the padding I'm going to use is just 5 pixels all the way across. Now, I'd like to be able to set the text. We could do it directly. I can actually just set this text property directly to a string. Alternatively, we can use the resources. If you remember when we used the designer, we had that funky syntax of @string that we could use, and it pulls these resources out of this string table. Let's go ahead and do the same thing here. I'm going to go ahead and create a price label string. I'm going to say enter total price. I'm going to create a second string. Let's call this calculate tip button. We'll set the value to calculate tip. And then let's go ahead and change our application name to be tip space calculator. Let's go back to our activity. Now, instead of setting the text via the property, I can set it via this method setText. And notice one of the parameters that you can pass in here is the resource ID. So we can say resources, or rather resource, string, and notice it's not showing up yet. That's because we haven't actually built this project to see the new string table. So I'm just going to go ahead and comment this out for a moment and just go ahead and build the application. So the system takes this string resource and runs this build action here of Android resource against it. Once I've done that, we can then see that we have our string resources here. So a common technique here is to go ahead and supply all your string resources up front, decide what they're going to be and what their names are, build the app, and then you'll have them available in the code behind if you'd like to use it. If you're using the designer, this isn't as big of an issue because the designer will kind of track some of that for you. So we can go ahead and set our text on this, and then I just need to add this into my panel. So I'm going to say layout, add view, price label. That'll put that at the top of the layout element itself. Then let's go ahead and put an editable text piece here. So we'll call this our price edit. Again, passing in our context. And then we can set some specific properties on this. So I'm going to set the input type. This is an input types enumeration, and the one that I want is actually number flag decimal. That will allow me to enter a decimal. Ultimately, this will actually translate the on-screen keyboard to show a number pad with decimals. And so that's useful for the user of our application so that they don't have to switch to a number pad. Let's put a padding on this as well. And then let's add this to the view. Then let's create our button. Let's go ahead and set our text for this. We'll set that to the calculate tip button that we put in there already. Let's go ahead and set our padding on here as well. Now for the button, I'm going to go ahead and set a left padding of 5, but then I would like a little more space on the top and bottom, and so I'm going to adjust those to be 10. And then we'll add this into our view. And then finally, let's go ahead and create a label that we can then display our results in. So I'll call this results label. Let's set the text size to be something reasonably large. Let's go ahead and set the text color as well. And so I'm going to set this to be the color yellow. So notice there's a series of predefined colors that are part of an enumeration here that's in this color class. It's actually a series of properties that we can set. And then we can go ahead and add this to our view. We should go ahead and put a padding on this as well, just to make it look the same. Okay, now I'm going to go ahead and use the set content view, but instead of actually passing in a resource ID that would identify the layout XML that I want to use, I'm going to go ahead and just pass it this panel that we created. So we can pass a view element. All of these things, text view, button, edit view, and the linear layout, are all views. And so we can set our content view to be this single view object, and it will then display that panel with all the elements in it. Now we need to provide some behavior for this application. So let's go ahead and take our calculate button and let's wire up to the click event. And so just like we did in Xamarin Studio, I can supply a delegate or an anonymous method or a lambda. Ultimately, those will all be translated to the same thing. And we can simply put our logic in here. So I want to calculate the tips for a series of tip amounts. And so let me just go ahead and create a nice little array here of, say, 10%, 15%, and 20%. Okay, so those will be the valid tip amounts that we'll calculate prices for. Let's go ahead and pick our price out. So we'll say if double try parse, passing in that price edit. All right, so that's where we typed our price in. Let's go get the text out of that and put it into our price element. If this is successful, then I would like to go ahead and go calculate the tips for each one of those prices. I'm going to go ahead and put this into a string builder. Now, notice that there's actually two different string builders available to me. We have one here in Java Lang, and we have one in System Text. The Java Lang version is the one that would actually ship with Android, and that's going to be a Java-based string builder. I don't actually want to use that one. I want to use the one that's in System Text. And so I'm going to go ahead and create one from the System Text string builder. So this is one of those areas that you're going to want to be a little bit cautious of. There are some classes that are repeated in both frameworks, and so you just want to look and see which one you're using. Sometimes it won't matter. They'll have similar functionality, but in this particular case, the string builder that's in Java doesn't have any overload to be able to format strings. I would have to format them and then add them to the string builder, and so I'm going to use the one in .NET that actually does both in one step. So once I have my tip amount, we can then do a for each against each one of these tip amounts, and then go ahead and calculate my tip. That would be the tip times the price. Then let's go ahead and add in to our string builder using append format. Let's go ahead and take the first one as a percentage. Second one will be currency. And the third one will be currency. And so the first one will be our tip amount, or the percentage of the tip. Then we'll go ahead and pick up the calculated tip. And then let's go ahead and take the calculated tip and add it to the price so that the user sees the total that we expect to pay. We'll just make it easier for them. Then let's just go ahead and put a blank line in there. Once we've done that, we can then take our results label and set the text to the string builder's contents. And that will then display the tip amount. Okay? So you can see that we've been able to build now an application completely in code. Right? So this would then create this UI and build it in code. Now, there are advantages to this. I have a little more control, and of course I can kind of structure it dynamically. So if I wanted to remove things or add things dynamically based upon some sort of setting, or based upon the version of the app, or based upon the license that the user has for this application, then I could do this right here in code. But ultimately, I think most of the time you're going to end up using the layout. And so in that case, we would just right-click on this, say Add New Item. So we'd open up this dialog. And the one that we want here is this Android layout. This creates a new AXML file, which is, again, the design file that we would use with the designer to be able to then edit this graphically and add our controls to it. All right, now before we actually execute this, I want to point out real quickly that Visual Studio actually has a new toolbar in here as well. If we right-click on our toolbars, you can see that there's a new Xamarin Android toolbar that's been added in here, specifically because I installed Xamarin. In this Xamarin toolbar, I can actually open up the same emulator manager that we had available to us on the Mac side. So you can see here my Android virtual devices. I've already got one here that I could start. It's an Intel version. And then I have the same device definitions as well. And I can, of course, create them here. I can also open up the Android SDK manager. So this is where I would be able to then download any particular tools or any version of the emulator that I'd like to be able to use. You can see that I haven't updated this in a while, and so there's some new things that are available if I would like to install those. Now, what I'm going to do in this particular case is I'm actually going to use a virtual machine. And so notice there's a drop down that's in this toolbar as well that actually lets me select the specific device that I'd like to run this code on. So this is an emulated version, and this is a virtual machine that I've already started that's running in VMware. What I've done is download an Android x86 ISO image, and I've installed it into this virtual machine. Now, in order to make this virtual machine accessible from Visual Studio, I need to do a couple of steps. I'm going to go to the virtual machine itself, and I'm going to identify the IP address of this virtual machine so that I can tell the Android SDK to connect to it. We're going to actually use a special keystroke that's available, which is Alt F1, to switch us into the command line shell of the Linux operating system that's actually underlying Android. And what I want to see here is what my Ethernet address is. And so notice it's 172.16.186.132. And so then I'm going to go to my command line here, and specifically what I want to run is this Open Android SDK folder. Okay, so if you have a start menu, then you could just use that and find this. This will give me my SDK folder. Now, this tool that I'm about to run is actually a command line tool, so I'm just going to go ahead and copy this path and run the command line. And I just want to go ahead and go to that folder. So I'm just going to paste it in. So here is the folder from the Windows perspective, and I'm going to go to the Platform Tools directory. And what I want to run here is something called ADB. ADB allows me to then connect to this virtual machine and then be able to use this IP address. And so the IP address again was 172.16.186.132. So we're going to say 172.16.132. And we should see that it gets connected here. Now in this case, I'd already connected it once before, and so I'm already connected to this device. So then I'm just going to switch back to it and use Alt F7 to get back to the UI. Then I can go to Visual Studio. I see my VMware in the list here, and now I can just click Start. When I do this, it will go ahead and build the tip calculator, and you can see it's going through all the steps here, and it's going to go ahead and install it and run it on this virtual machine. And there we go, we get our tip calculator. So now I can enter my total price here, where I could say my total meal price was $100, calculate the tip. That would be $10 for a total of $110, $15, and $20. And so you can see that we now have our tip calculator that we've built, and we've successfully executed it inside my Android virtual machine. Another way to debug your application is to install it onto a physical device. To do this, you actually have to turn on the debugging options on the device so that you can connect a USB cable and get Visual Studio or Xamarin Studio to see the physical device. I can simulate that with my VMware image. I'm going to go to the settings, and I'm going to locate the debug options. On earlier versions of Android, you'll find a debugging menu option here under System, but notice that we don't have one on this device here. This is Android 4.3, and so I'm going to go to the About tablet, and I'm going to scroll down and find the build number here. And I'm going to go ahead and click on this build number a few times. And notice I get a little prompt. I'm now 2 steps away from being a developer, 1 step away. It pronounces me a developer. Don't you wish it was that easy? And then I get developer options here within the tablet itself. And in the developer options, I can then enable this. So that turns on the menu. And I can say, yes, I would like to use this for development purposes. And I'm going to do a couple of things. I'm going to say, go ahead and stay awake so it never sleeps. And I'm going to enable USB debugging. So once I've turned this on, I can then use this device to be able to deploy my application to for testing purposes. In this introductory module, you've seen how Xamarin Android allows you to use the development skills, tools, and frameworks you already possess to build mobile applications that target the popular Android operating system. You can design, develop, and debug your applications either using the included Xamarin Studio, which runs on Mac OS or Windows, or with Visual Studio on Windows. You can then test those applications on a physical device or in a created emulator or virtual machine image. Finally, You can sell your application through one of the many Android marketplaces or deploy it privately within a corporate infrastructure or website. Xamarin Android provides a better programming experience than the native platform with a modern compiler and highly optimized runtime. You can leverage all the features of Android, and your application runs as a native executable, so it's fast. You can even use it to build games, which tend to be the most demanding applications. Even better, when the code is structured properly, Xamarin enables a cross-platform capability with other dominant mobile platforms, namely iOS and Windows Phone, so you can share the application logic and not have to rewrite it for each target, saving you time and money.